Hi everyone, my name is Ritika and in today's video I will talk about electrophiles, nucleophiles, very basic, very simple, but this video will also tell you what is not an electrophile and nucleophile also. So let's try to understand that, okay? Now, in physics, chemistry, bio, English, maths, wherever, everywhere actually, okay, the word phile means loving. Okay, when I say phile, electrophilic means something which is in love with electrons. Okay, when I say something is nucleophilic means something is in love with nucleus. Okay, when I say hydrophilic, something is in love with hydro means water. If it rings a bell, if not, that's also fine. My point being that electrophilic species are the species which are in love with electrons, and electrons are negatively charged species, as you all know. So electrophilic species basically will try to go towards an electron or electronegative center or a negative center, negatively charged space. Okay, so, with that logic, with the knowledge of electrostatic forces of attraction, we can say that electrophiles must have a positive charge because they are moving towards negative, but that is not true. Okay, so for example, if we have a cation, let's say if we have a methane cation, okay, so this is a methane cation is having a positive charge, will definitely try to go towards a negative center because it needs electrons, right? So that's a good example. So this is definitely a electrophile, okay? But let's say if I talk about a C carbon and oxygen bond. Okay, now in a carbon oxygen bond, and this carbon is actually having four bonds, so it is not having any bond less. Still, this carbon oxygen bond, because of the high electronegativity of oxygen, it attracts the shared pair towards itself, leaving carbon a little, you know, electron deficient in that way. So it has a small delta positive charge, not exact positive charge like we have on the methane cation, but it has a small positive charge because the electron density of this bond is shifted towards this oxygen because this oxygen is a very high electronegative center. Okay, so that will make this carbon a electrophilic center even though this doesn't have any positive charge, right? And there are many more examples like that. Now, third example being your sodium plus. Okay, now is sodium plus a electrophile or not? Pause this video, think. Okay, but if you think it is electrophile because it has a positive charge, no, definitely not. Na positive is not an electrophile, definitely not. Why? Because we all know that Na positive is a very, 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 very high electropositive metal. It reacts with air even. Not air, actually water. Okay, it reacts with water and it will just quickly form Na positive and it will give out this one electron. It will kick out the one electron, okay, because it wants to achieve the noble gas configuration. Now, if sodium is doing this, so aggressively, it is kicking out its one electron to become Na positive, okay, and it wants to become Na positive, why will it be attracted towards electrons? It too wants to kick out electron. Huh? If it is doing that itself, it will not be attracted towards electrons anymore. So even though Na positive is having a positive charge, it is not a species which is in love with electrons or a negatively charged center because it has given out, it has become stable now, right? So this is an example where a species, even after having a positive charge, is not an electrophile. Okay. Now, then we have also we have cases like BF3. Okay, well, BF3, this is actually a Lewis acid. We all know this is an electron deficient center. Okay, and this also is going to act as a new electrophile even though it is not having a positive charge. Okay, because this is electron deficient, right? So my point being, electron deficiency is not the same as needing electrons. Okay, Na positive is electron deficient. It has one less electron, but it is happy. It just wants to do that, right? Okay. Moving on, we have nucleophiles. Now, nucleophiles, on the other hand, exactly the same, okay, species which are actually attracted towards positive centers because nucleus is a positive center. Nucleus is something which only has neutrons and protons. Neutrons do not have any charge, protons have a positive charge, right? But nucleophiles are really the species which want to donate electrons. They have extra with them, so they would like to donate it to other species or to electrophilic centers. Okay, so with that respect, we have example of any, let's say we have any carbon ion, we have a carbon with a negative charge. Carbon with a negative charge is not stable. It wants to give away that negative charge. That's why carbon is having a higher electron density, which can be used to donate it to a positive center. That's why it is a nucleophile. Okay. We have OH minus, and we have many other also with a negative charge. Okay. But for example, we have an alkene. Okay. Now, any alkene, even though these carbons they have full electrons, okay? But these alkene, as we know, it is a pi bond. So one is a sigma bond, and pi bond is like electron density above and below it, right? Now this high electron density above and below my single bond is actually a negatively charged center because it is electron density, right? Even though this is not actually a negative charge, but it is electron density and it can be used to donate, right? So even a double bond, a pi bond is also a nucleophilic center, right? Then we have, let's say, ammonia. Now, ammonia, as we all know, is not a species with a negative charge, but still we know it has a lone pair here, right? And this lone pair is electron density. So basically, any electron density which can be used to donate, right? And bonus question here is Cl minus. Now, Cl minus is a very famous nucleophile. We have seen this in a lot of nucleophilic reactions. Okay, I just told you how Na positive is not an electrophile, but my friends, I'm telling you, Cl minus is a nucleophile because even though Cl minus is also stable that way, but it is electron density. It is high. It has a high electron density to on it, and it can be used to donate it to other electrophilic centers. That is why Cl minus is also a nucleophile, right? So I think by the end of this video, you know that it's not true that all the positively charged species are only electrophiles. Basically, species which need electrons, okay, they may and may not be positively charged are electrophiles. And for nucleophiles, all the species which have extra electron density, it may be in form of lone pair, it may be in form of negative charge, it may be in form of pi bonds, okay? But it is high electron density and it can be used to donate it to other centers, the electrophilic centers, okay? So I hope this is clear to all of you. And if you have any questions, well, you can comment. But I hope you know what is not an electrophile nucleophile also by the end of this video. So thank you so much for watching.